high voltage. Have you ever seen a motor control diagram and felt confused or thought this is too complicated to understand? What if I tell you that by the end of this explanation, this entire diagram will feel simple and logical? Watch till the end, because once you understand this, every motor control circuit will start making sense. Welcome to Electriverse. This diagram represents a direct online starter for a three-phase induction motor with complete power circuit, control circuit, and protection. Let us start from the power supply. We have a three-phase supply, R, S, and T, 400 volts AC. This supply first enters the main circuit breaker, Q1. This breaker provides short-circuit protection and allows safe isolation of the system. If Q1 is off, nothing in this circuit can operate. From the breaker, the power flows into the contactor, KM1. The contactor is an electrically operated switch. When its coil is energized, the main contacts close and power flows to the motor. When the coil is de-energized, the contacts open and the motor stops. Below the contactor, we have the thermal overload relay, F1. This relay protects the motor from overload conditions. If the motor draws excess current for a long time, the thermal relay trips. When it trips, the normally closed contact, 95 to 96, opens. This breaks the control circuit and the motor stops safely. Now let us look at the motor connection. The three-phase motor M1 is connected through a terminal block. This ensures proper wiring, easy maintenance, and safe testing. Now we move to the control circuit. The control supply is 230 volts AC taken from phase and neutral. This supply is protected by a differential breaker which ensures personal safety. Then the supply passes through a single-phase protective device, Q2. Now we reach the push buttons. The stop button is normally closed and the start button is normally open. When the stop button is pressed, the circuit opens and the motor stops. When the start button is pressed, the control circuit is completed and the contactor coil energizes. Once the contactor energizes, an auxiliary contact, 13 to 14, closes. This auxiliary contact provides a holding path, also known as a self-holding or seal-in circuit. This allows the motor to continue running even after the start button is released. Now let us understand the indication lamps. The green lamp indicates motor running condition. The red lamp indicates motor stopped or tripped condition. These lamps provide instant visual feedback to the operator. Now let us see the complete operation. Main breaker on, control supply healthy, start button pressed, contactor energizes, motor starts, green lamp turns on. If overload occurs, thermal relay trips, contactor drops, motor stops, red lamp turns on. This system provides safe operation, clear indication, and reliable motor protection. If this explanation helped you understand motor control circuits clearly, like this video. Share it with fellow electrical learners. Subscribe to Electriverse for more simple and powerful electrical knowledge. You have been watching Electriverse, where every spark tells a story. Stay charged, stay safe, and happy learning.